In the last video, we started calculating definite integrals where we were given a table of values for for a function and its first derivative and its second derivative, and we were able to calculate a definite integral of the first derivative of a function by recognizing that f is an antiderivative of f prime. And so based on that, we could use the fundamental theorem of calculus and just subtract two values of f from each other to find a definite integral of f prime. Whew, that was a lot. We're going to see a couple more problems that are just taking this idea and expanding it just a little bit in ways that are not quite described here. We'll describe them better in about 10 pages, but it's stuff that I think you're not going to have any trouble believing. Let's see the problems. All right, so here we want to calculate the value of the definite integral from -1 to +3 of f prime of x plus f double prime of x dx. Okay, so the first part about this is that this is the sum of two functions. So how do you think I can calculate the definite integral? Let me write it like this. Let's say I have the definite integral from a to b of f of x plus g of x dx. How do you think I could solve that? Well, the nice thing about integrals is that they behave kind of well in kind of the same way that we found derivatives worked. So all we need to do is we need to take the integral of f of x dx and add the integral from a to b of g of x dx. So we can just break this into two different integrals. And we could describe this as f of x from a to b plus g of x if we know antiderivatives of those two functions. Okay? So in this case, we do know an antiderivative of f prime because we have said that f is an antiderivative of f prime. So this is f of x from -1 to 3. And the second part is the second derivative of x. So do we know an antiderivative of the second derivative of x? Well, we know that the second derivative is the derivative of the first derivative. So therefore, the first derivative is an antiderivative of the second derivative. You do not need to put this on a Post-it note and stick it on your bathroom mirror if you don't want to. As long as you remember this, you can kind of understand that you just take one step up the chart to find the antiderivative of the second derivative. So the antiderivative of the second derivative is the first derivative. So to figure out that, we're going to calculate the first derivative of x, evaluated from -1 to 3. All right, and so that is f of 3 minus f of -1 plus f prime of 3 minus f prime of -1. And then we just need to take those numbers out of the table and substitute them in here. And off we go. F of 3 is 1. F of -1 is 0. F prime of 3 is 3. F prime of -1 is 1. So that is 1 plus 2, or a final answer of 3. Okay, so we find the definite integral of the sum of two functions by breaking it into two individual functions and finding the integrals of both. Problem 3 says, what's the value of the definite integral from 1 to 3 of 3 times the second derivative of x dx? Here, we're not adding two functions together, but we're taking some function and multiplying it by a constant. So how do you think we can calculate that? Well, it's the same thing. So if we wanted to calculate the derivative from a to b of some constant k times f of x, that's just pulling the constant out of the definite integral. I should throw some dx's in here. So that's k times f of x evaluated from a to b. All right. And so in this case, that is just 3 times, what is the antiderivative of the second derivative? The antiderivative of the second derivative is the first derivative. So that's the first derivative of x evaluated from 1 to 5, which is f prime of 5 minus f prime of 1. F prime of 5 is 2. F prime of 1 is 0. And so that gives us an answer of 6. And the last problem here is, what is the value of the definite integral from -3 to +3 of 1/2 f prime of x plus 2 times f double prime of x? So I'm not even going to pretend that this is hard. It's just 1/2 of the antiderivative of the first derivative, evaluated from -3 to +3, plus 2 times the antiderivative of the second derivative of x, again, from -3 to 3. All right, so f of 3 is 1. F of -3 is 4. F prime of 3 is 3. F prime of -3 is -2. Okay, so that's 1/2 times -3 plus 2 times 5, which is -1.5 plus 10, which is equal to 8.5. All right, so the point of this is that definite integrals of combined functions behave kind of like we would be used to, at least as far as adding two functions, subtracting two functions, and having a function multiplied by a constant. If you have two functions multiplied together, it gets weird in a hurry, so don't expect it to work there. But for addition, subtraction, and constant multiples, that is going to be fine. So that is how you would calculate definite integrals in that sense. In the next video, we're going to tackle the last two problems, which are a little bit interesting, something we handled a little bit way back when we were talking about derivatives. But what we'll see is that as we get on, we're bringing together all of what we've been learning in calculus together, as we're seeing problems that get closer and closer to the kinds of multi-part questions they actually ask on the AP exam.